Okay, guys, in the last video, we learned about constructors, which allows to define some rules before our object is utilized. Again, we got to remember that these rules are there so that the object, when it's used properly. So think of it as a car. When the car is bought, we need to make sure that the car has fuel and it has engine oil. If those two things are not there, well, the car might not start. It might actually break the engine and it will fail, right? So every time we initialize an instance of an object, we need to assure ourselves that the object is properly initialized, properly set the correct values it needs to, so that the object could be utilized correctly, right? In our example, we said that a person needs to have a name before it's utilized. If they don't have a name, what's going to happen is, well, it's always going to say null when that object is talking, that instance of person, okay? And we also talked about how we cannot call our constructor ever again by doing person, let's say this. If we put in the new keyword in front, we're creating a new instance of that object person. So this is not good either because it's not the current object. Some people might even say, well, this specifies this object, so we could probably do something like this. But then again, the constructor is only done at the initial part of your object creation, of the instance of that object being created. That's the moment it does it. Anytime after, it's not possible to call the constructor, right? So this, you'll notice if we put our mouse over it, we got an error that says, well, this can't happen here. It has to be inside the constructor. Well, why can I call itself inside the constructor? Well, now we created a different type of error where we created an infinite loop where it calls itself, right? We talked about having a blank here, recursion. We're calling our own method many times, and in this case, infinitely. So you could see we have another error, recursive constructor invocation, and it never ends. This is not good. However, we're allowed to call constructors within a constructor. When would we ever want to do that? Well, we know it is when we have a method overloading. And in this case, it would be a constructor overloading. If you don't remember, an overload works when you have the same method name, or in this case, the same constructor name, with a different signature, a method signature. In this case, inside Java, the method signature would be the parameters. So here you could see that these two constructors are different because the method names are different. So if I wanted to, I could create a new person where the name is no name. So no name has been initialized, so we don't know what's going on. But it still works, right? Which basically means now I have two types of object that I could have. Sorry, two initialization of person, two new instance when it gets created by two different ways. Would I want to do that? Yeah, sometimes. Many times we would have a car where it has, let's say, a turbo engine in there. So we want to initialize it to set it up for a turbo engine, right? It happens that we have different variations or different ways of initializing something. So in both cases, we're creating an instance of person. Just that one initializes the name with JSON and one that initializes it with no name. Now, last thing that's really important of when you're overloading with a constructor is a lot of times where you have multiple code that's similar, we could just basically call the other constructor inside one constructor. So over here, you could see that both cases we're setting up the name. It's not the idealist thing, but why not put all the same code in the same place? So here, rather than saying name equals no name, we could just call the other method, the other constructor, and say no name, right? By doing this, oops, sorry, here it's not person, it's this. By doing this, we're keeping our code in the same location. So if ever in 20 years or whenever we come back to this, the only place we need to modify the logic of our code would be in this constructor rather than every location where I do a modification to name. Right? So this is an important aspect. So we could have done more stuff here. We could have said, well, I don't know. Let's say this height. Well, actually, we don't need the this because there's no conflict. So we could say height equals, I don't know, by default 3F. Right? Weight, I don't know, by default 100. Okay? So now you could see that the similarity is being done, right? This little call will call this constructor, will get that new name, which is no name. And then the height and the weight is still done in both cases. So in both cases, we'll see the value of height being 3 and the weight being 100, right? So the overloading works everywhere. We learned that about method overloading. See the previous videos. And we could utilize it for a constructor, or we could utilize it for other parts of our class. Cool. I'll see you guys in the next video.